Hi, chemistry students. This is your lesson on Introduction to the Mole. And as you're going through this lesson, just remember the mole is just another unit, but it's an incredibly important one in chemistry. And it's important that you understand what it is and how to use it. For this lesson, you're going to need a calculator with an exponent key. So be sure you have one before you dive in. Okay, you're also going to want to take notes in your notebook or on paper. In particular, you're going to probably want to write down some of the example problems so you have them as a reference when you are doing problems for this particular unit. Now, in our class this year, this is Unit 6, and so on your notes, you're going to want to put the title, Unit 6, the Mole, and write the date. You may also want to copy down what the purpose of this unit is. So here it is. Number 1 says atoms and molecules are too small to count by the usual means. A mole is a way of counting this type of very small particle efficiently by grouping an amount that is visible to the naked eye. So again, atoms, molecules, or this thing called formula units that we'll understand soon are incredibly small. And so we have to have a lot of them put together in order to see them. We use moles in chemistry in many different situations and therefore need to be proficient in calculating amounts in moles. And at its base, a mole is just equal to 6.02 times 10 to the 23rd particles. Now, I want to just have you recognize that a mole is exactly like a dozen and how easy it is to figure out how many dozen we have or how many we have if we have a certain number of dozen. A dozen is 12, just like a mole is 6.02 times 10 to the 23rd. Dozen is very convenient for counting things that we can see, like eggs and donuts. It's much easier to group eggs in a dozen eggs to bring home for our breakfast than to have, just bringing home one egg at a time. It's much easier to bring donuts to a party or to a breakfast in a package of a dozen or several packages of a dozen than it is to try to bring individual donuts. So a dozen is really convenient for these types of things. Now, it's not good for atoms or molecules because atoms and molecules are so very small that you still wouldn't be able to see a dozen atoms or molecules. So we just need a much bigger number to group them in. Now, this is at its core just going to be a dimensional analysis problem. And as you remember from previous unit, dimensional analysis is the method of converting units. And we use conversion factors to help us decide whether we multiply or divide. So when you look at a problem, you find in the problem something that has a number with a unit. And then you find in the problem something that says how many. You're trying to change one unit like centimeters to inches. So if it says 15 centimeters is how many inches? We're going to put 15 centimeters here as our given. We're going to put inches as our, I want to figure out how many inches that is. And then we're going to use the conversion factor of 1 inch is 2.54 centimeters in order to figure out what that conversion is. So we're going to do the same thing with moles. We're going to use this T-chart format to make sure we understand whether we multiply or divide. So just to go back to this. A mole has been defined by the chemistry union to be this exact amount. 1 mole is 6.02214076 times 10 to the 23rd. Now, it used to be based on carbon atoms, but now, and just in the last 4 or 5 years, they decided just to call it this number, okay? Just like 1 dozen is 12, well, 1 mole is this number, 6.02214076 times 10 to the 23rd. Now, for calculations we're going to do in class, we're just going to round that to 3 significant figures of 6.02 times 10 to the 23rd. And yes, you're going to have to memorize that. All right. Now, just to give you an idea of why that's a useful number, this is a picture of 5 elements and 1 mole of each of those elements. So this is a picture of a group, 6.02 times 10 to the 23rd atoms of, in this first one, carbon. 6.02 times 10 to the 23rd atoms of sulfur. In this one right here, 6.02 times 10 to the 23rd atoms of mercury, 6.02 times 10 to the 23rd atoms of copper, 6.02 times 10 to the 23rd atoms of iron nails. So you can see those are an amount, even though it's a huge number of atoms, it's an amount we can see. So it's easy, like if somebody says, please bring me a mole of carbon, you could actually see it, all right? Just like if you wanted to get a dozen eggs, it's a convenient amount for eggs. All right. Now, just so you know, this number actually has a special name. It's called Avogadro's number, and you will see it referred to that. And so I want you to be aware of that. So you may want to write down that 6.02 times 10 to the 23rd is called Avogadro's number, and it's named in honor of this Italian chemist Amedeo Avogadro. All right, so I want to give you a sense of the scale of this, all right? Just going back, like here's a mole of carbon, okay? In this little sample here of carbon, we have 6.02 times 10 to the 23rd atoms of carbon. They're very, very small, okay? So if I were to take that little sample of carbon and take all the atoms in carbon and blow up the atoms to the size of standard soft drink cans, those soft drink cans would cover the surface of the Earth to a depth of over 200 miles. Think about how big that is and how small the carbon atoms must be. Give you another comparison. If you had Avogadro's number of unpopped popcorn kernels and spread them across the United States of America, the country would be covered in popcorn to a depth of over 9 miles. Okay, now I also want you to realize that grouping them is very efficient. If I were to say to you, student, I need you to count out for me a mole of carbon atoms. So start counting. So you start 1 carbon atom, 2 carbon atoms, 3 carbon atoms, and you're going to count all the way up to 6.02 times 10 to the 23rd. Think about that. That would be, after this decimal point, 23 more places, 23 more zeros. So how long would that take you? Well, if you were able to count atoms at a rate of 10 million per second, it would take about 2 billion years to count the atoms in 1 mole. So you're hoping I'm not going to give you that as an assignment. You could not count them out individually. We're going to have to group them, and there are efficient ways to do that. But right now, we just want to go between this unit, the mole, and the amount of 6.02 times 10 to the 23rd. Okay, so just to go over this one more time. If I were to say to you, I have 1 mole of helium, that would mean I have 6.02 times 10 to the 23rd helium atoms. If I were to say to you, I have 1 mole of hydrogen, and hydrogen is diatomic, that would mean I have 6.02 times 10 to the 23rd H2 molecules, okay? If I were to say I have a mole of H2O, of water, that would mean I have 6.02 times 10 to the 23rd H2O molecules. If I had 1 mole of lithium, that would mean I have 6.02 times 10 to the 23rd lithium atoms. Now, if I had 1 mole of donuts, that would mean I have 6.02 times 10 to the 23rd donuts, but we would be drowning in donuts. These things are much smaller amounts. And so do you see how that works? Okay, so to do these problems, you're going to need to know how to enter exponents in your calculator. So you're going to add 6.02, and you're going to find the EE or the exponent button on your particular calculator, and you're going to enter 23. You're going to see 6.02 E23, and that means 6.02 times 10 to the 23rd. Some of the smaller calculators we have here will show you this, but again, that will mean 6.02 times 10 to the 23rd. I want to reiterate that if you try to put in your calculator times 10 to the 23rd, you had better put this in parentheses, because if you don't, when you do a division, the logic of your calculator will fail you. You'll see as you do these problems. So be sure that you either see it looking like this, or you see it, you put this in parentheses before you do the calculation. Okay, so let's do a few calculations using Avogadro's number. So here is our conversion factor. 1 mole is 6.02 times 10 to the 23rd particles, and that could be atoms or that could be molecules. So it says how many atoms of lithium are in 3.50 moles of lithium. Let's set up our T-chart. Okay, we look for the number. That is 3.5 moles. We look for the how many, that's where we're going, to atoms, and we have our conversion factor. And we just have to decide whether we put the mole on the bottom or the top, and that'll tell us whether we multiply or divide. So I know I want to cancel moles, so I'm going to put, I'm going to put moles on the bottom, and I'm going to put 6.02 times 10 to the 23rd atoms on top, because an atom is a particle. So that is just when you're beside, you multiply. When you're below, you divide. So this would just be 3.5 times 6.02 times 10 to the 23rd divided by 1. Now, we're going to use 3 significant figures. So whatever you get in your calculator, you're going to round to 3 significant figures. If you do that, you're going to get 2.11 times 10 to the 24th atoms. Okay, atoms of lithium. Let's look at another one. This time it says how many moles of lithium are 3.35 times 10 to the 24th atoms of lithium. So again, we're going to do our T-chart. There, and we start with the thing that's the number. We look for the how many. So the unit we're going for is the mole. And then we're going to arrange our conversion factors so we can cancel units. So again, that's going to go on the bottom. A mole is going to go on the top. So what carries through is moles. That's what we want to convert to. Now this is where it's going to be really important that you don't, you put this in parentheses or you use the exponent button, okay? Because if you remember, this is making something big into something small. We're trying to group it like, 12 donuts is 1 dozen. So this many atoms is a small number of moles, not a large number of moles. So if you do this correctly in your calculator, you're going to get 5.56. If you do it incorrectly, you're going to get 5.56 times 10 to the 46th, which is a huge number. And that's because you entered 6.02 times 10 to the 23rd wrong in your calculator. You just said, instead of doing dividing by times 10 to the 23rd, you multiplied by the 23rd. And that's why you got that huge number. See your teacher if you're having trouble with this, but if you got some sort of huge exponent, just put 6.02 times 10 to the 23rd in parentheses or use your exponent button. Okay, so let's do a couple in your calculator and see if you get the right answer. And here are a couple of possible answers so you can sort of check yourself. So 5.61 moles of iron is how many atoms of iron? Pause the video, try it. Okay, I'm back. I hope you have a number. You should have gotten 3.38 times 10 to the 24th atoms of iron. Okay? Let's try another one. Okay, you've got 9.31 times 10 to the 24th atoms of iron, and I want to know how many moles. And again, remember, the point of a mole is to make it a smaller number, not a bigger number. So try this one, pause the video, and when you're ready, okay, I'm back. So let's see what you got. You should have gotten 15.5 moles if you did it correctly. If you got something big like 49 or 46, that doesn't make any sense, all right? A mole is supposed to be a grouping number, a smaller number. So you entered the exponents in wrong. Okay, so little riddle from here from Chemistry Cat just to end the video. What do you get when you cut an avocado in 6.02 times 10 to the 23rd pieces? An avocado into lots of small pieces. What do you get, Chemistry Cat? You get guacamole. Get it? Guacamole. You know, mole? Ha-ha. In any event, I hope you had a good time learning about the mole. Now you're going to want to try some of the practice problems that your teacher has given you.